Okay, we're going over the midterm review part 1, question number 1. The state of matter in which material has a definite volume but no definite shape. So it says states of matter. So what are our 3 options for states of matter? Okay, solid, liquid, and gas. Out of these 3, okay, it says it has a definite volume. So solid fits. Solid has a definite volume. But does solid have no definite shape? No, solid has a definite shape. So that's why that one's up. A gas, a definite volume. Gas does not have a definite volume. Gas will fill up whatever space it's in. So gas is up. Therefore, the answer is liquid. And that was for number 1. Number 2. Number 2, you're looking at these diagrams. These are the same ones that will be on your exam. The homogeneous mixture in the illustration above is in container A, B, C, or D. C and B are out because those are heterogeneous. You can see different colors of something in it, okay? Homogeneous means it looks like something clear. You can't see other particles in it. The correct answer is A. Number 3, an example of a chemical change. There's lots of examples of chemical changes. They happen all the time. You could have put rust, milk going sour, Number 4, what are the 4 indications of a chemical reaction? Precipitation, or precipitate. A precipitate is anything left over after a chemical reaction that wasn't there to begin with. An example is, let's say you mix 2 liquids together and then now you have some new cloudy substance or maybe salt left over. Altering the substance. For instance, when you burn a piece of paper or a wick, you no longer have the paper or the wick. It's now burnt substance or ash. Color change. And light or heat formed. I'll give you a second to write these down. Number 5 lists 4 ways that can be used to separate mixtures. What we've used before is a filter or filtration. You can also do distillation, evaporation, and paper chromatography. It's where you put some chemicals together and you can see the pigments separate from each other. We don't do it in this class. Number 6, in the diagram above, what does number 8 refer to? It's going to be the atomic number. Number 7, the total number of protons and neutrons in the nucleus of an atom is mass number. For number 8, how many neutrons does sulfur have? So if you remember ape man, the mass number minus the atomic number equals the neutrons. So 34 minus 16, and that's going to give us the neutrons. How many electrons are in a chlorine ion? So it's charged. If you look really closely, it's given an extra electron. So normally what you would do is just look at the periodic table. find chlorine, it's right here. The atomic number is 17. So there's 17 protons and 17 electrons, except in this case it was given one more electron. So instead of 17 electrons, it's going to have 18 electrons. Number 10, omit. I'm going to start right here where it says how many protons, neutrons, and electrons does this atom have? You're just looking at the diagram and counting the dots. So for protons, it's the dark solid circles, and they're in the center. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the neutrons are the clear white circles. 12. And electrons. Electrons are in the electron cloud. That's all you had to do for that. You'll see this diagram as well. Just look at the key to figure out what's what. Number 11, atoms of the same element that have different masses are called what? It's the same atomic number, it's the same element, but it has a different mass. Isotopes. 12, why is an atom considered electrically neutral? This happens when electrons equal the number of protons. I know we haven't done average atomic mass for a while. That's number 13. It's a very two-step process. The percent right away changed to a decimal. Okay, so this ends up being 0.6525. I'm going to zoom in. So this could have, there's 2 different rows. It can have 3 rows, 4 rows. However many rows it has, you're going to do the same process. This ends up being 0.3475. Okay, so you just take the relative abundance, which is the percent, but you're changing the percent to a decimal, times the mass equals a number. And you do the same thing here. 0.3475 times the mass equals a number. You add them together, whether it's 2, 3, or 4 of them. You add them together and that's your final answer. So I'm going to type it in my calculator. 0.6525 times 22.98 equals 14.99. 0.3475 times 24.99 is 8.68, and then I add them together. I don't change anything with the mass. The mass stays the way that it is. The only thing I change is the percent, and I change it into a decimal. You can either move the decimal over or divide by 100. By adding these two together, I get 23.6, and that's your final answer. Number 14, that picture at the top looks like a chocolate chip cookie. Should look familiar with you when we did our atomic timeline. What scientist developed the plum pudding atomic model? J.J. Thomson. Within a group of elements, as the atomic number increases, the atomic radius increases. 16, as you move down the periodic table from carbon through lead, what happens to the atomic radius? So carbon's right here. It's asking you if you move down, what's happening to the atomic radius, the size of the atom. So generally it's not that big here, but as you move down the table, it increases in size. Okay, so it increases as you move down. For groups 13 through 18, how do you find valence electrons? It's talking specifically about these right here. We see 13, 14, 15, 16, 17, but in order to get how many valence electrons oxygen has, it's 16 minus 10. So this entire column has 6 valence electrons. So what the answer they're looking for is minus 10. It's the group number minus 10. Number 18, which column shown above represents the alkali earth metals? It's going to be B, because you're very, very smart. What's the name of column C? Halogens. And D? Yep, good job. 19, which type of wave has a frequency of approximately 10 to the 8th? And you're just looking for that number, which is right here. So TV and FM. Number 20, the atomic sublevel with the next highest energy after 4p. So all it's asking you is what comes after 4p. I'll do this once the long way. We have to go all the way to 4p. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This starts at 3d. D start at 3. 3d10. Then you go back to normal, 4p6, and after 4p6 is 5s2. And that would be the answer. After 4p is 5s. Draw the correct orbital diagram for a ground state nitrogen atom. All you have to do, this is the one with the box and the arrows, find the atomic number, which is 7. There needs to be 7 arrows total. You do have to do electron configuration first. We're not going very far. We're just going here where my finger is for nitrogen. So it's 1s2, 2s2, 2p, 1, 2, 3. 2p3. You don't go past where you need to go. You stop right on where you need to go, which is nitrogen. If it was an excited state, it did say ground state, but if it was an excited state, you go past where you're supposed to stop. You would keep going. But it said ground state. So we said 1s2, 2s2, and this was 2p. We only needed to go to 3. Okay. The arrows do have to go in opposite directions. And we only have 3 arrows in this last energy box. Okay, and the rule is you cannot double up. I couldn't have put 1, 2 here and put the third one here. You cannot double up in the boxes until you go all the way through that specific energy level. Another way to check if you did it right, nitrogen was atomic number 7. You can add up these as well, and it should total 7. 3, 4, 5, 6, 7, and you should have 7 arrows as well. Number 22, if an element has an octet of electrons, how many electrons are there? So when you hear the word octet or octagon or octopus, what number comes to mind? 8. That's what octet means. The smallest unit of an element that can exist either alone or in combination with other particles of the same or different elements is an atom. Number 24, Mendeleev predicted that the spaces in his periodic table represented undiscovered elements. Number 25, draw the trends for each, for the atomic radius, ionization, energy, and electronegativity. So we'll do this for the radius, energy, let's abbreviate, and electronegativity. Atomic radius is the only one that does the opposite of the other two. So it's increasing as you go this way. Radius is the size, so it's small, small. It gets larger as you go down and to the left. Ionization energy increases as you go up and to the right, the same thing as electronegativity. Number 26, list the property of noble gases that make it different from all the other elements. Okay. Unreactive. Same thing if you see the word inert. Number 27, a measure of the ability of an atom in a chemical compound to attract electrons. So when I hear the word attract or attraction, I think of positive and negative, charges. And the correct answer is electronegativity. Let's scoot this up. In order to do number 28, you will see a chart like this. This is just a guide, like a key. Okay, so to do number 28, you do need to use that chart. Based on its electronegativity difference, a difference is subtraction, okay, what kind of bond? So just do 4.0 minus 3.5. This is for number 25. Oh, 28. Sorry. It's for number 28. So I got 0.5. So this type of bond is polar covalent. So it's really easy. We're going to do another one, and you just use this chart, subtract. You're not going to get a negative number, okay? If you do, then subtract the other way. Number 29, malleability, ductility, and conductivity are characteristics of substances with metallic bonds. Number 30, magnesium, atomic number 12. What group does magnesium belong to? 2. How many electrons can you fit into the D level? This is also asking, how many arrows fit in the D block? 10. What about the S block? How many fit in S? 2. And then the P block? Yes. Good job. Number 32, draw the Lewis structure for hydrogen chloride. The Lewis dot structure, it's the same thing as valence. Well, it's not the same thing, but it's just a clue. Valence dots. Okay, so to find the valence, just a reminder, this whole column, the valence electrons are 1. This has 2 valence over here, 3 valence, 4, 5, 6, 7. Those are valence electrons. Those are the dots that you'll put around each. So H, we said was 1 dot. Here's H. And then it's chlorine. We'll have 7. Okay. 1, 2, 3, 4, 5, 6, 7. I'll zoom in. Number 33, what is the electron configuration for nitrogen? We did that when we did the box orbitals. 1s2, 2s2, 2p3. The atomic number is 7. These little numbers that look like exponents should add up to 7. The region outside the nucleus where an electron can most probably be found is the electron cloud. The main energy level that can hold only 2 electrons is the first. It's also the S block. 36. Hydrogen has electronegativity of 2.1. Fluorine has 4.0. Subtract those. I get 1.9. Where does 1.9 fall here? Ionic. So this is an ionic bond.